NASA is an organization that is extremely adept in collecting data, conducting missions. After a mission has been run and hundreds of millions have been spent, the only tangible asset that comes back to Earth is data. The data archives that NASA has are humongous, are vast, but it is very hard to retrieve the data and visualize the data in a proper, holistic way.
There's so much data. The data for the moon and the Earth is measured in, from terabytes to petabytes. So it's very difficult to deliver that kind of information.
Lunar Whirlwind is a NASA application, and it's a program that you can download from the internet. It's an open source program, and it allows you to visualize the lunar surface in 3D with topography, with images from the Clementine mission.
Whirlwind draws in many different types of data. It tries to seamlessly blend it all so that the user doesn't have this idea of there's these disjoint data sets. It's just all one big thing that just looks right. That might involve blending aerial or satellite imagery on top of elevation or topographic data. And then on top of that, you're adding point data sets and boundary lines for different things. And you're trying to do that all in a 3D world and give the illusion that this is it's realistic.
As you're zooming in on a particular location, Whirlwind's actually going out and looking at servers that contain the data, taking all that data dynamically, accessing it, wetting it together, and now putting that data on your system.
We originally designed Whirlwind to be as easy to use as possible. And so that means that it has to be used by the widest possible audience, anywhere from grade school to everyday users like myself. One thing that I had to pay particular attention to is when I bring random people up to actually use Whirlwind, I see how they move or how they use these certain controls in Whirlwind. And I realized, oh, that didn't work quite as I expected. And then I would go back to the drawing board and try to figure out what's an easier way, more intuitive way to implement certain features into Whirlwind.
The biggest challenge for the moon was just that the data was received in a very raw state. I wouldn't say that it was given to us in more or less the standard geographic formats that we're used to dealing with. And even when we try to convert them over to those standards, the moon has its own, it's a different radius than the Earth. We had problems with one data might be in metric and the other one might be in standard units, so we had to do unit conversions, and the fidelities or resolutions of the data didn't match up from the different sources we were applying, so we had to kind of blend those together in a kind of a seamless way.
There's no question about NASA research benefiting from this, because now it's making the data available that was available in just piecemeal fashion before. And on top of that, it can also be the portal for delivering all of the other spectral data that was collected that is necessary for scientific research.
Lunar Whirlwind is a demonstration project. It shows what is currently possible to do. You can pull off terabytes of data from servers remotely. You don't have to have the data locally on your system. But ultimately, it is determined with what you will do and what you can do with that data. And an essential part of the future will basically be to tie Whirlwind in as a missions, operations and planning tool. It can be tightly into mission scenarios. Scientists can work on geographic data mining, can work on planetary mapping, and they can do it in a truly distributed fashion.
So in the future, the library of information that Whirlwind has access to will only grow, and we look very forward to that.